All right, I know that we did these problems in class, but just to be safe, I wanted to make absolutely sure we were comfortable with the solutions to them. So I wanted to go ahead and actually work these out for you now. So an object is launched horizontally from a height of 20 meters above the ground with a speed of 15 meters per second. We want to determine a lot of things. The time it'll hit the ground, the horizontal distance it traveled, and the speed with which it hit the ground. And I should be clear, I'm going to say vertical speed like I did last time. So again, vertical. I should be much more clear on this. So first of all, x naught and y naught are always 0. That horizontal distance is actually the x that we're solving for. And just so you know, the time that it hits the ground is going to be t. And we will, in fact, get the speed with which it hits the ground in the second. And the vertical speed is going to be vy, just so you know. So I've got those written down here. So we got x naught is 0, x is unknown, v naught x. That is the 15 meters per second that we launch at horizontally. And our time is unknown. Now, y naught is 0. Y is the 20-meter height that we fall to the ground. V naught y. Well, we're launching horizontally, so that means our initial y speed is 0. Vy at the end is unknown. That's what we're going to be solving for. A is 10 because it's gravity, and t is unknown. So let's go ahead and get the time at which it'll hit the ground. So for part A, I will simply say s equal, whoops. So I will say y equals 1/2 a t squared plus v naught y times t plus y naught. Now let's go ahead and plug in our numbers. So we have 20 equals 1/2 times 10 times t squared. We'll go ahead and solve for t squared. So I get 20 equals 5t squared. Divide by 5. And we're going to get 4 equals t squared. And then when we simplify that, we're going to end up getting that t equals 2 seconds. Yippee! Now, for part B, the horizontal distance it traveled, that is going to be, we use the x equation, x equals v naught x times t plus x naught. So let's plug in our numbers. X is going to be, well, we're going to use the 15 meters per second times this 2 seconds that we calculated. So we end up getting 30 meters. And finally, for part C, we want to know the speed with which it hit the ground in the y direction. So that's going to be vy equals at plus vy naught. Let's plug in our numbers. So vy is going to equal 10 times the 2 seconds plus 0. So that's how we're getting 20 meters per second for part C. So that's question number 7.